Can you see my screen? Can anyone please confirm?
Yes, sir.
Okay, so let's start with today's session. So, good evening, everyone. Welcome to all of you for the first live interaction session for the NPTEL course MATLAB based programming lab in chemical engineering. So, before starting anything, let me give you my introduction. So, I am Prasil Kapadia and I have completed my BTech from SVNIT Surat in 2019. After that, I have worked in Reliance Industries Limited at Jamnagar side. I have worked there for a year, and mostly I have used S Pen Plus software there, and I have good grip on that software, and I have learned that software there. After that, I joined IIT Kharagpur, and I completed my masters from there in 2022. During my IIT Kharagpur master's course masters, there was one course of design lab where this Professor Parag Deshpande he taught us MATLAB course. So I have also learned from him. So I completed my masters in 2022 and currently I am pursuing my PhD from IIT Bombay. So just for those students who are interested, this is my personal web page and this is my LinkedIn and YouTube ID. So whoever is interested, you can send a request or you can follow in this YouTube channel. All the videos of this MATLAB course will be available. I will be uploading there, and I guess you will also get a link of all individual lectures available on YouTube. So this is all from my side. I hope you all. How many of you have joined right now? Can I see? Okay, there are many students. So I assume most of you are from chemical engineering background. Hello, please respond. Karthik.
Y- Yes, sir.
Yes, you are from chemical engineering background. Other than you, I guess everyone will be from chemical engineering background only because this course is mostly for chemical engineers. And I just want to know if anyone has used MATLAB previously, or this is the first time that you are enrolling in such a course. Anyone, please willing to respond? Okay, no one is willing to share. So, are you having any knowledge other than MATLAB programming?
Yes, sir. I have already used Spin Plus, Spin as HDRI, Super Pro Designer. There are so many tools I have used, but I didn't use MATLAB. It's my first time.
Okay, this is for your first time. Okay. Anyone other than Manish? Your name is Manish, right? Yeah. Okay. Anyone other than him willing to share? No. Is this something? I guess no. Okay. You silent. Okay. Uddhav. Okay. Okay. So I assume that this is the first time most of you are learning this. So, what we will do, we will parallelly, what I will do, I assume that first of all you have completed all your week one lectures taught by sir. So, in this every Monday's 2 hour lecture, what we will do, I will try to revise whatever is taught by sir in the class, and then we will take some examples. Those are not given in your assignment, plus those are not solved by sir in the lectures. So we'll take some new examples and I will try to give you better experience with MATLAB. And in my previous SPEN course on NPTEL, what I used to do, I used to teach some particular problem, and I used to call students to share their screen and show me how to solve the problem. So that also builds individuals' confidence. So if this is also possible, we will do it. Okay, one thing I want to ask you: Are you guys having MATLAB license? Did you get it, or you have not got yet? I don't know. I want to know. Can anyone respond, please? Manish, is it provided by Professor Parag or
Yes, sir, but I'm using online MATLAB because I'm not unable to access on the laptop. So
Okay, okay, okay. So let's start with today's session. So before starting today's MATLAB session, let's just quickly go through this first slide that was taught by sir in that is the basis of any chemical engineering when you are in second or third year where you are introduced with core chemical engineering courses. This is the first diagram that you are familiar with, that says that you are having your raw material as input, then you do some physical operations that changes its temperature, pressure, composition or something, or size, maybe size. You are having granules and you are willing to change it into powder. So those kind of physical operations you do. Then all this input is when input is ready, you send it to the reactor where your reaction occurs. So after reaction, what happens? You are having your reaction products plus some byproducts plus as well as some unreacted reactants are left. So what you need to do, let's say your target product is benzene and you are with benzene you are getting some other toluene, phenol, other things. So to get a particular component you need to do again some physical operations, and then after doing that physical operation you get your final output product. So can anyone give me one example of this kind of one plant example that uses that follows every plant follows this kind of example, but can anyone give me one example from your chemical technology course? Can anyone do it, please? You have learned so many chemical engineering processes in your chemical technology course, so can anyone tell me one example of plant, one manufacturing product example? Okay, I guess no one is willing to say. So I will show you one example, that is acetone manufacturing unit. So this is the acetone manufacturing unit. So acetone is manufactured from dehydrogenation of isopropanol. So what happens? Isopropanol, the reaction is isopropanol is getting converted into acetone plus hydrogen. So this is a gas phase reaction, and this reaction occurs at high temperature and high pressure. So pressure is generally 3 to 4 atmospheric pressure and temperature is 400 to 500 degree Celsius. So what does this process flow diagram says? From storage, isopropanol is sent, and it is, what does this symbol means? By steam, we are heating our isopropanol. So from this, and this recycled isopropanol is also mixed. So isopropanol is first heated into some heat exchanger. After heating isopropanol, we are passing it through the compressor because we need our reaction is occurring at 3 to 4 atmospheric pressure. So 4 to 5 atmospheric pressure. Okay. So this 4 to 5 atmospheric pressure, we need to achieve it via compressor. So we pass it through the compressor. Then after compressing, our feed isopropanol is ready for the reaction. So this is tubular catalytic reactor in which isopropanol is passed through the tubes and this flue gas is passed to the cell. So here dehydrogenation reaction occurs. What is dehydrogenation means? Dehydrogenation means hydrogen is removed. So from isopropanol, the reaction is isopropanol giving acetone plus H2. So H2 is removed. So this is dehydrogenation reaction. So now what will we be having after this reaction? We'll be having unreacted isopropanol, then formation of H2 gas and formation of acetone. So now what we need to do, we need to separate all three components. So for that, what we are doing first, we are condensing this reaction product and we are passing it to the water scrubber. So what water scrubbers do, we pass water from the top. So what will happen? H2 is comparatively light gas. So it will eventually get separated from the condensed liquid acetone and isopropanol. So now we are having three components. H2 is separated, but we are having one additional component, that is acetone. With acetone and isopropanol, we are having addition of water. Now we are having three components. So to separate three components, general thumb rule to separate n components based on their relative volatility, or in general words to say based on their boiling points, what we need to do, we need to do distillation. So for n components, if we are willing to some separate n components, we need n minus 1 distillation column. So as we are having three components, we need 3 minus 1 two distillation columns. So if we check the boiling point of all three components, so I have written it down. Acetone's boiling point is 56 degrees Celsius. Isopropanol's boiling point is 82.3 degrees Celsius, and water's we all know it is 100 degrees Celsius. So what will happen? Acetone having the least boiling point. So in the first distillation column, what will happen? Acetone will be obtained as a vapor phase from vapor or liquid based on this based on this condenser condition. We will get acetone. Now, acetone is separated. So what we are having? We are having water and isopropanol. So in water and isopropanol, water's boiling point is higher. So it will be obtained from bottom. So whatever water is obtained, we just need to recycle it to the water scrubber. And from the top, isopropanol is obtained. So whatever isopropanol is obtained, we need to recycle it. So there is no waste isopropanol. We can reuse it for the this catalytic reactor to convert it for the acetone. I hope this process is clear to everyone. Can anyone respond? So this is one example of chemical engineering plant where we prepared our raw material, then we heated it to give it our, if we compare it with this diagram, we did some physical operations, then we passed it to the reactor. From reactor, this is the reactor. We got products, and now we need to do some physical separation, and after physical separation we got our desired product. Is this plant acetone manufacturing plant clear to everyone? What is the process? We are coming to why we need MATLAB, but is this process clear to everyone? Manish,
Yes,
Uddhav will back in. Okay, someone is writing in Q&A. Please speak. It is better. You have got the license. Okay. So, okay, I have two questions I will ask. Based on your chemical engineering knowledge, you try to respond. There is nothing right or wrong. I just want you to speak. Okay. So, my first question is here. As we know, the temperature of the reactor is 500 degrees Celsius. So, what we did, we passed isopropanol through the heat exchanger, and then we passed it through the compressor. So can we do it reverse? Let's say I am passing my isopropanol first to the compressor and then heat exchanger. Can I do it? Is it possible to do it in reverse manner instead of heat exchanger, then compressor? I would like to do compressor and heat exchanger. After first compressor, then heat exchanger. Can I do it? Can I do it? What does compressor do? What is the rule of compressor? Compressor increases the pressure of the vapor stream, and it is most important part to remember that compressor always needs its feed as vapor. Okay, so there is one hint I have given to you. So can I first pass it through the compressor and then heat exchanger? Can anyone tell me? Manish, based on your understanding, what will happen if I am just passing it through the compressor first and then heating it? Okay, so I will tell. Let's say,
Can I tell it? Like,
yes, Rohit. Hi, Rohit. Welcome back.
hi. Faisal. Compressor, when you pass gas through compressor, the temperature automatically rises because the
Yes.
compressor, what it does, it actually binds the molecules when it compresses, and because of which there will be a release in energy. The temperature will automatically rise, and you
Yes.
need to cool down the gases, not heat it up.
Okay. No, so Okay, your whatever you told that is correct. But my question is, can I do it reverse? Can I first pass it through the compressor and then heat exchanger? Can I do it?
Heat exchanger, whether it is cooling down or it is
No,
heating
it
up.
is heating. Our purpose is to heat the mixture. Our
Yeah,
purpose is to heat the isopropanol.
if downstream
See this,
uh,
I passed my isopropanol to heater. I heated it using steam, and then I passed it to the compressor. So compressor conditions are such that it is ready to feed our reactor at 4 to 5 atmospheric pressure and 500 degrees Celsius. So can I do it first? Let me pass it to the compressor and then let me go through the heat exchanger. Can I do it?
uh,
What
it depends,
what
like
what
suction
issue
of
one can?
compressor conditions,
Okay.
suction
Okay,
of
tell
the
me.
compressor.
Okay, I told you one thing. Let's say in my compressor, I'm just giving you a condition. Let's say, uh, because of some compressing, I'm compressing my gas. Let's say something is converted into liquid. So is it feasible if something like that happened? Is it feasible for my compressor?
No, no, not feasible.
What will happen?
Compressor shaft will be damaged.
Yeah, it will be damaged. So for the safety, what we should do, we should first increase the temperature of gas. It should be enough. Uh, Temperature should be enough that by it when we are compressing it, it should not cause this kind of issues. So one reason is just to be safe on this side that somehow liquid is not getting entered into the compressor.
Compressor.
One more reason, can anyone tell me? Let's say I'm heating it first. So what will happen? What is the kinetic energy of liquid is higher or kinetic energy of vapor is higher? Obviously kinetic energy of gas is higher. So what will happen when I increase the temperature? I am already having some good amount of kinetic energy. So that increased kinetic energy we are directly adding to the compressor. So what will happen? It will reduce the workload for the compressor. Is that correct?
Yes.
So these are the two reasons. You should note it down. Maybe it's not relevant right now for our MATLAB course, but this is something fundamental to chemical engineering. So these are the two reasons. Okay, I have one more question here. I told that isopropanol is passed through the tubes while my flue gas is passed to the cell. So, can anyone think of the reason why it is not passed to the tubes and in cells, in cell site? Can anyone think of it? What can be the reason? These are basically kind of your gate question that you get.
Falling materials are always passed through tubes.
Okay. Okay, so your reason is correct, but here what is happening? Okay, what is flue gas? Can anyone tell me? Oh, you all know it is some, I have written it down, gases emitted from combustion processes. So those are mainly gases like CO2, H2O, N2, NO, NOx, CO2. So these kind of gases are called some particular mixture that is called flue gas. So this flue gas is highly corrosive in nature. Okay, so the if corrosion is occurring, we should pass it through the tube as Rohit said. So you are correct. But what is other than corrosion? What is main factor we are having here? We are having here the very high pressure. So to avoid any kind of what we can say unwanted events, we pass it through the cell. So what happens when I pass it through the corrosive material through the cell? It is easier to clean it. Am I right? One on the safety purpose and second on cleaning purpose. Okay, so this was the plant. Okay, so let's list down the equipments those are involved here. So we are having one storage tank, right? Then one heat exchanger, then one compressor. Let's say if I am having liquid, then I will be having pump, not a compressor. Then I am having a reactor. Then I am having distillation column. So, okay, what are the modern softwares using which we can simulate this kind of process? Can anyone?
Aspen plus.
Maybe Aspen Hysis kind of thing.
Yes. Okay, you are correct. We can use, okay, let's go for S pen plus. So S pen plus I can use. So what is their S pen is doing? Let's say I am choosing a distillation column in S pen. I am giving my feed and product bottom and top product I am giving. I am just mentioning the conditions. Let's say I am having this temperature, this much pressure, and this much composition, this much reflux ratio. So what is S pen actually doing? Is it doing some magic that I am writing something and it is giving me answers?
It is actually using the chemical engineering principles, formulas,
Chemical
and
engineering
this
principles.
solve.
What are the actual principles? Let's see if I am going for distillation. So distillation column is mathematical model of distillation column is available. And
Yes,
okay, I will show you. Then it will be more clear for you.
it is like
So
it is using McCabe-Thiele method to calculate the number of theoretical stages.
yes. Yes, McCabe-Thiele conservative method to calculate number of trays. Okay, but here I am talking about modeling of distillation column. So here, what we generally do in a distillation column or in any kind of column, what we do, we perform overall material balance. Then we perform individual component material balance. Then we perform energy balance. Then we have equilibrium relation and we have mole fraction summation relation. So what does total material balance do? Total inlet should be equal to total outlet. Correct? That should always be followed. But let's say in a distillation unit, I am just focusing on a tray. So let's say this is the tray of a, okay, let me draw it down. Let's say this is the tray of the, sorry, let's say this is the tray of the distillation column. So liquid will be falling from here and vapor will be from here. So let's say liquid flow rate is Ln plus 1 and vapor flow rate is Vn minus 1. So from here, this is the nth tray. So this is Ln and this is Vn. Okay, my drawing is not good at all, but I guess it is understandable. This is the tray. On tray nth, liquid is coming from top tray, that is n plus 1. So Ln plus 1. Vapor comes from top to bottom, bottom to top. So that vapor flow rate is Vn minus 1. So that is entering, and what is leaving from entry? Ln and Vn. So this is my overall mass balance. Ln plus 1 plus Vn minus overall mass balance of a particular tree. Ln plus 1 plus Vn minus 1 minus Ln minus Vn. At steady state, it will be equal to 0. But not in steady state, it is dmn by dt. And what is it? What is this mn term? Does anyone know? I'm not sure if you have studied this kind of modeling or not. Can anyone tell what is mn? Mn is called liquid holdup. And what is liquid holdup? Liquid holdup is the volume of liquid that remains in a particular part of distillation column. Let's say in this tray. So some particular amount of liquid will always be remaining there in the on the tray. So that is called liquid holdup. So this dmn by dt is equal to ln plus 1 plus vn minus 1 minus ln minus vn. Let's say I am having 50 number of trays. So how many equations will be there for total material balance? 50. Correct? Am I right?
I think 49.
Okay, 49. One. Okay. Okay, let me write down 49. Okay. Now, let's say I'm having mixture of just two components, benzene and toluene. Let's go for three components, benzene, toluene, and xylene. So for each component, there will be mass balance. So what I will be doing, I will be just multiplying individual L and V by their mole fraction of individual components. So I have just multiplied it, X representing liquid mole fraction and Y representing vapor mole fraction. So I have just done this, and Mn is liquid holdup, so it will be Xn on that particular tray. So let's say I am having three components, benzene, toluene, and xylene. How many equations will be here? On each tray, let's say there are three components, so we can write it for two, three. Third will be one minus both. So let's say we are just focusing on benzene and toluene. So how many on each tray there will be two equation, and let's say I'm having 50 trays, 49. So how many equations we will be those will be here? Those will be 98 equations. Correct? Correct? Guys, please respond. I can't see any one of you.
Yes.
Okay. So are you getting what I am telling you, or you are not understanding? Please stop me. Okay. So now let's say after that, what will we be having? We will be having energy balance. So energy balance also on each tray. So there will be 49 energy balance. Now we need to solve equilibrium relationship to find the Y composition. So okay, what is Raoult's law? If anyone knows, I just need a mathematical statement. What is Rolle's law? Y into P is equal to X into P set. This is applicable in which conditions? When my gas is also ideal and my liquid solution is also ideal. We generally consider that gas phase is ideal, but if liquid phase is not ideal, that is generally not ideal. Liquid phase is generally non-ideal. So that non-ideality is introduced by gamma, that is activity coefficient. So we need to solve this equilibrium relation also, and we need to solve this summation of this must be satisfied, that summation of x is equal to 1 and summation of y is equal to 1. Let's say I add this. Let's say I'm not focusing these two, but I am just focusing on these three total terms. How many equations we will be having?
196.
196. And we need to solve these 196 equations simultaneously, right? It's not like let me first individually solve this, then individually. It's not like that. I need to solve these equations simultaneously. So how can I do that? This is what SPEN does. That when you choose your distillation column, let's say I'm just talking about distillation right now. So let's say when I'm choosing my model as distillation column. So when I choose this model, it automatically takes care of this equation. So our main, okay, when I was teaching SPEN course, the use of SPEN was I showed it like instead of doing all these things on pen and paper or writing a code, if we are having uh, inbuilt things available like this software, MATLAB SPEN is available. So why not to use that software to solve this? But let's say if you want to learn this thing, how can I model my system, how can I, because everything is not available, every model is not available, every small things, let's say you want to solve multiple equations, it's not available, that you will be going for SPEN, right? So those kind of things you need to do it by your own, and for that you can't take pen and paper. So you need to know, you need to have some basic knowledge of programming. So this is the motivation of going for MATLAB and even SPEN also. If one want to escape from MATLAB, so this is the motivation for SPEN, that you don't need to solve all these equations. And MATLAB, we need to learn how we can solve these individual equations. So this is the motivation of this MATLAB course. Okay, is this clear to everyone? Is anyone having any doubts? Okay, so let's move ahead. So MATLAB. So what is the full form of MATLAB? MATLAB is Matrix Laboratory, and it is a commercial software. What does the word commercial software mean? Can anyone tell me? What is commercial software?
Paid.
It
It
is
is
used by, utilized by industry in production.
commercial meaning you need license to use that software. Like if you know S Pen Plus is not like I will download it and I will be able to use it, right? I have to pay to use actual version. Let's say DW Sim. How many of you know about DW Sim software?
It is a free site.
Yeah,
Yes.
it's free. You don't need license, but MATLAB, to use MATLAB you need license. So that is commercial software. And in most of the, at least I don't know about industries, but in most of the educational institutions, this MATLAB they already purchased, and it is relatively cheaper for education institutes compared to industries. Rohit, are you having MATLAB Aspen licenses?
Aspen, as of now, like in my company, they provide only
Yes.
three licenses. Like only three
Yeah,
people can
because
use simultaneously.
Aspen is really really costly.
Yes, and only three people can use it at a time. There are
Yeah,
about 1,000 employees in my company, and
yeah, and
three
that
is very less.
is very so painful. And MATLAB, I don't know if you know it.
MATLAB, no, we don't have any access to MATLAB as of now.
Reliance, when I was working, there were only overall Reliance was having total 45 Aspen licenses. So only 45 at once 45 people can use it like that. So
Even now,
45 is a huge
NPTEL
number.
Aspen Plus, there are only 150 commercial use, matlab, at a time use. Only 150
Yes.
people across India can use it.
Yes. Aspen is so costly to use. Okay. So MATLAB is a commercial software and its full form is Matrix Laboratory. So this MATLAB was developed and it was presented in 1984 at IEEE conference on decision and control in Las Vegas. So what is it? It is programming and numeric computing platform. What is programming and numeric computing means? Okay, tell me. The name itself says what is programming platform and numeric computing platform. I guess this part is taught by sir in week 2 lecture, but just a basic as we are starting from MATLAB. What is programming? Programming means I will be writing my code or I will be using some inbuilt function to do some kind of to know some kind of profile variations or something. And what is numeric computing? Numeric computing means let's say I want to in very basic say basic words, let's say I want to calculate 5 plus 3 is equal to 8. So that is numeric computing. So those kind of numeric computing also we can do using MATLAB. So it is a high level computing language and we can do computational analysis, control signal processing and communication fields it is used. So with MATLAB is there is something you can also install with MATLAB that is Simulink and that Simulink is mainly used for this process control application. So we'll not going there, but this is what MATLAB is. Okay, so what are we? It's what can we do? I'm sorry for this mistake. Okay, it's okay. So what can we do with MATLAB? So first of all, we can plot our data. So what kind of plotting can we do? Can this is really simple. Can anyone tell me something from your chemical engineering example? Let's say what kind of data can we can plot? Let's say I can plot concentration versus time. How concentration is reducing with time. Then any other example? This is really simple. Just say some examples. What can you plot? Manish, your final year, so you must know something. We all used to use graph paper. So what did you plot on graph paper? Graph paper. You plotted LNP side versus 1 by T you may have plotted. What else? Rohit?
I think we
Uh,
can feed some
as of
codes like uh, matrix and vectors kind of thing.
No, I'm talking about plotting. What kind of
we can
XY plots?
we can plot the variation of mole fraction with respect to pressure.
Yeah, we can, yeah, exactly. PX diagram. Then I can plot TX diagram. And I can plot XY equilibrium relations, right? So these are chemical engineering applications. So this we can plot. Plotting is not specific to chemical engineering. We can plot anything, but as we are talking about chemical engineering perspective, so that's why I'm willing to know some chemical engineering examples. So these all are correct. Okay, now this is one thing that I can plot. Now, second thing is data fitting. So can anyone give me example of data fitting? One is sure that everyone have done in your BTech labs. One example of data plotting, data fitting, not plotting, sorry, data fitting. Everyone must have done it, I know. One example. In your chemical reaction engineering lab, I have given you hint. Please tell me. You know it and you have done it. Guys, Sambhu, can you tell me from chemical reaction engineering CRE part, what can you fit?
Sorry, actually, I'm pursuing the BTech now, so I
Sorry, you are?
chemical react. Yeah, I'm pursuing actually BTech.
Okay.
So
Anyone other than him? Okay, so let me tell you, let's say you are doing an experiment when you are willing to find the order of the reaction, right? So what you do, you measure your concentration of the reactant at some particular time interval, and then you plot concentration versus time. And you are having your n is equal to when your order of reaction is 1, it should follow particular kind of equation. N is equal to 2, it should follow particular kind of equation. So what is that? That is nothing but we are fitting your data. You are first checking for n is equal to 1. If it's fitting, if it's not fitting, you go for n is equal to 2, n is equal to 0, n is equal to 3. So that is nothing but data fitting that you all have done in your chemical reaction engineering lab. Or if you have not done yet, you will do it. That is for sure. Okay, any other example? Can anyone give me from thermodynamics? What you can do? What else you can plot? What else you can fit? Sorry. These you have not performed any experiment, but if you know, let's say I want to, let's say I am having this data of T set versus, I don't know why it's not writing, P set and temperature. You are having this table of P set versus temperature, and you want to fit it in kind of equation that is ln P set is equal to A minus B divided by T plus C. So what is this equation called? Antony type equation that you have used in your thermodynamics, where A, B, and C constants are given to you in your back part of that J.M. Smith Introduction to Thermodynamics book. So those A, B, and C constants, how are they fitted? You know experimental data of P set and T on wide range of temperature, and from that this data is fitted, and you can whatever you are using your constants A, B, and C that you get from there. So this is one example of data fitting that we can do. Okay, are you understanding it or not? Please tell me. Okay, then one more example is eccentric factor, but I will leave it for now. Okay, then you can also do numerical integration. So there are various rules, Simpson's one-third rule, Simpson's, what are the other rules? Can anyone tell me? Trapezoidal rule, Simpson's one-third rule, and Simpson's 3/8 rule, right? At least those who are preparing for GATE, they know. Okay, then we deal with nonlinear equations. So one example of nonlinear equation from chemical engineering thermodynamics. Non-linear equation. Anyone? What is non-linear? Where power is not one. Let's say x square minus 2x plus 1 is equal to 0. That is a non-linear equation. So what is that kind of equation that you have dealt with in your thermodynamics? Anyone willing to tell? Okay, cubic equation of states. P minus P plus A by V square. V minus B is equal to RT. So this is non-linear equation. Correct. This equation, van der Waals, different constants A, B, sorry, different constants of sigma, epsilon, omega, psi, zc, and alpha. So based on the equation of state, these constants will be different. So if you write it down, this equation, it will be in form of a into v cube plus b into v square plus c into v plus d is equal to 0. So that is nonlinear equation, and this kind of equation we can solve it using MATLAB. Then other part is friction factor. So when we are dealing with laminar flow, so friction factor is given by F is equal to 64 by Reynolds number. And we are dealing with turbulent flow. This is the weird, this we can directly calculate, right? Reynolds number is nothing but rho V d by mu. So if we put the values of rho V d and mu, we can directly calculate friction factor. But for turbulent flow, this kind of equation 1 by square root of F plus 2 log k by 3.7 plus 2.51 divided by Reynolds number into square root of f is equal to 0. So how can you solve this? Because f is everywhere. So this kind of equation, this is called nonlinear equation, and this also you can directly solve using MATLAB. Either you can use Newton-Raphson method. These I hope everyone must have studied Newton-Raphson method, then bisection method, all those things. But MATLAB, we can directly solve it using some inbuilt function. So we don't need to write a code to solve this kind of equation. So this we will be able to do using MATLAB. Then linear equation. So linear equation example, can anyone give me? We have already discussed it in the beginning of the lectures. So can anyone tell me one example of linear equation at steady state? Distillation column, correct? Distillation column, let's say I want to perform the material balance over distillation column. So inlet is equal to outlet. So that is nothing. If we see here, and if we consider this part as zero total material, this dmn by dt, dm x by dt, all this term if we consider zero, so this is nothing but a linear equation. So these simultaneous linear equations also we can solve using MATLAB. So this was mass, I'm sorry. Yeah, this was mass balance in distillation column. And one other example is heat transfer through the cylinder that you have already studied in your heat transfer course. Let's say when there is convection, let's say from hot fluid to wall. So it is 2 pi r h into A into delta T. So h into 2 pi r L into T1 minus T2. Then wall to wall conduction is this kind of equation. And let's say you want to solve this equation for temperatures. So all this temperature, in the temperature, these equations are linear equations. So this is something you can also solve using MATLAB. Now, various example, we can also predict vapor liquid equilibria where we can do flash calculation. Flash calculation, those who are in Aspen course, you know, we need to choose a flash drum and we can provide the conditions. So we can perform flash calculation, we can find bubble point and dew point temperatures. We can plot TXY and PXY diagrams. Then other than that, we can solve initial value ordinary differential equation. What is initial value ordinary differential equation? Initial value meaning at t is equal to 0, we are given some condition. So best example for initial value problems are when let's say CSTR is in series. CSTR is in series, or one reaction is occurring in series where A is converting into B, B is converting into C. So can anyone tell me how can I write this equation A to B to C? Mathematical equation, can anyone tell me? Let's say A to B to C. So I will write dCA by dt is equal to minus K1 into CA. Correct? So dCB by dt is equal to K1 into CA because B is formed, minus K2 into CB because B is used to form C. And for the third reaction, dC by dt is equal to K3 into concentration of C. So this kind of equation, what we know at T is equal to 0. Let's say I am taking A is equal to 100 moles per liter and B and C is 0. So that is called initial value condition. And as it is unsteady state, so that is called initial value ordinary differential equation. And similarly for boundary value problem, what is boundary value? Meaning at the, let's say this is the rod I am having. This is the rod I am having, and at the rod x is equal to 0. I know some temperature Ti and x is equal to L. I know the temperature, that is T is equal to TL. So these kind of problems are called boundary value ordinary differential equation. One another example is this reaction in catalyst 4. Right? Thiele modulus derivation, if you know, d square Ca by dx square is equal to K by dAb into Ca, where and this at the center of the pore, it is maximum, and when you come out, it is zero. So this kind of equations we can solve, and we are going to solve with MATLAB. So we'll get started with MATLAB now. So is this clear to everyone, students? No one is responding, so I don't know if you are understanding anything or not.
Yeah, we
Uh,
can proceed further, sir.
Sorry, you are not clearly audible. Can you repeat?
Yeah, we can proceed further, sir. Though I don't have vast knowledge about it, but I can grasp it.
Okay, very good. Manish, are you getting everything that I am saying?
Yes,
Ro-
sir, of course. It is introductory part, so
Okay.
that I am not.
Okay, but please respond. I am not understanding if you are understanding everything that I am saying it or not. And if you are not getting something,
Okay.
please stop me at that particular point and I can explain you. Okay, so let's get started with MATLAB. So I've already opened MATLAB and I am having 2024A, and I am having this academic license, so it is academic use only. So this is the MATLAB window. When I open it, it looks like this. So this part of this MATLAB window is called tool strip. You don't need to remember all these names, but this is just for sir has already covered this thing. So I am just telling it. So here when I press a new script. So here I can write down my own code. Then new live script meaning you don't need to save it actually, and you can without saving you can run your code. So that is live script. Then new script, these are the same way. Then open is meaning, let's say I have already written something and I want to open it. So this is how this open works. Save we already know. Then these are various other tools. Layout you can change, but for me this is the best layout. Okay, so this is tool scripts. This was home part. Then plots. So these are the various kinds of plots. This part is not enabled right now because we are not having any data. So these are the various plots that we can use. There is nothing favorite actually, but I don't know why it's showing like that. Contour plot, histograms, scatter plot, then area plots, log plots. These various plots you can do, surface plots. So this is what you can do with plots. And then there are some apps. Apps are like class diagram. Okay, I don't know about this part, apps, because I have not used anything from here. So these are some apps part. Now, this is called the where my cursor is here right now. That is called, okay, that is called command window. And this is called this workspace. Okay, so let's say I'm writing something, a is equal to 3. Okay, so as soon as I wrote down a is equal to 3 on my command window, that a variable is stored in this workspace. So if I click here, so what is a? A is 1 cross 1 matrix where it is one row and one column. Okay, so what I did, I kept a is equal to 3 like this, but let's say I am writing after semicolon. So what I will get, a is stored, but it is not shown on command window. Let's say I'm writing b is equal to some value 10 and I'm putting a semicolon. So what will happen? It will not show it here, but that variable is saved in workspace. So b is also 1 cross 1 matrix. So this is what we can do with very basic operation. Let's say now I want to do summation. Let's say C is equal to A plus B. So C is 13. And as I have not kept semicolon here, so I can see this window, I can see this value getting printed out here. So can anyone tell me what can be the benefits of using semicolon and not using semicolon at some particular place? Let's say if you are writing, you are having a 100-line code, and you want to focus on some particular values at line number 10, and you want to know at every as soon as code is running, you want to show that at line 10 what is the value that it is getting printed. So for that case, what you can do, you don't need to write those f printing and all. You can just directly remove semicolon, so it will print it down at your this command window. So this is plus thing. Now let's say I want to write a matrix. So let's say a is equal to 1 comma 2. 1 comma 2, no, only 1 and 2. And I'm pressing enter. So what is it doing? What is this kind of matrix called? This is a row matrix or column matrix. Guys, A is row matrix or column matrix? There is only one row and two columns. So only one row, so it is called row matrix. So when you are willing to define row, you don't need to put any kind of commas in between. But let's say I want to define a column. So one, then I will put one semicolon and then I will keep two and I will close the bracket. So it will be printing it like this is the way of printing it in form of column. Okay. So now let's say I want to define 2 cross 2 matrix. 1, 2, 3, 4. I want to define 1, 2, 3, 4. So can anyone tell me how will I write 1 and 2 in first row and 3 and 4 in second row? Can anyone help me? This is really basic thing. Please respond. Anyone?
Can you repeat the questions?
Let's say I want to write it down like, okay, let me write it down here so it will be clear to you. I want A is equal to this kind of matrix 1, 2, 3, 4. I want to print it something like this. So how can I write it in this command window? 1, 2 and 3, 4. 1, 2 is my first row and 3, 4 is my second row. So how can I write it? Rows are written like this and columns are written by putting one semicolon in between individual elements. So how can I write 1, 2, 3, 4 in 2 cross 2 matrix?
I think after 1, 2, commas will be there.
Okay, you tell me how should I write 1, then 1, 2, then please say it's fine if you are wrong.
Yeah, 1, 2, then comma, then 3, 4.
Semicolon, not comma. Okay. I don't know if comma works or not. No, comma doesn't work. No, comma doesn't work. It is semicolon. Not semicolon. This is not semicolon. This is not called semicolon. This is also kind of comma. Okay. So this is 1, 2, and 3, 4. Okay. So let's say, okay, again, I'm going A is equal to 1, comma 2, and I want to find a transpose of the matrix. What is transpose of matrix? If my A is 1 and 1, comma 2, so what should I get when I do the transpose of A? What should I get? What should I get? This is my A matrix. Sorry. Yeah, this is my A matrix 1, comma 2, and I want to get a transpose. So what will happen? All rows will be converted into columns, right? So my transpose is calculated by putting this symbol. So this will give you transpose of a matrix. Or I guess you can also write a transpose thing. Something like this. Yeah, transpose also you can, this is inbuilt function. So you can also get like this. So this is my C matrix, this is C. So let's say I want to find a transpose of this. So what should I get if I am calculating the transpose? What should I get? Manish, what should I get when I calculate transpose of C shown on screen? I should get 1, 2 in first column and 3, 4 in second column. So let's say C transpose. So this 1, 2, it is here 1, 2
Sorry.
and hello.
Yeah. Did you say
Okay.
something?
I asked like this is my C matrix 1, 2 3, 4. What will I get by transposing matrix C? What should be
It
my
1, 3, 4. Like in the column we will do 1, 2, and in the second column we will 3.
yeah. So 1, 2 is in first column and 3, 4 is in the second column. Okay, let's say I'm defining one 3 cross 3 matrix. A is equal to 1, 2, 3. This is my first row. After that first row, I will add this kind of comma 4, 5, 6, and 7, 8, 9. So what will I get? 1, 2, 3, 4, 5, 6, 7, 8, 9. Guys, just a minute. Give me a minute. I'm sorry. Okay. I guess I'm visible now. Okay. So what I did, I wrote 1, 2, 3. After that, I put one semicolon, and then 4, 5, 6, one semicolon, 7, 8, 9, one semicolon. Okay, now let me tell you, I want to find eigenvalues of A. How can I find eigenvalues? Okay, what is eigenvalues? How can I do it mathematically? How can I find eigenvalues? Does anyone know the procedure of finding eigenvalues? A minus determinant of A minus lambda should be is equal to 0, correct? And you solve it and you get eigenvalues, right? So here we don't need to do anything like that. I can just write eigen. I guess it is just eigen of A. So no, it's not eigen. Okay, EIG, not eigen. It is EIG of A. So EIG of A will give me eigenvalues. So this is the command to find eigenvalues of matrix. So it is a 3 cross 3 matrix. I will be having three eigenvalues. Let's say I am having 2 cross 2 matrix 1, comma 2, 4, comma 1. And let's say I want to find eigenvalue of A. So I will be having two eigenvalues. Okay. Is this clear, everyone? Let's say now I want to find the rank of matrix. So I will write rank of A. So it will give me the rank of matrix. So that rank is 2. Let's say my matrix is this one and I want to find the rank. So I can find rank of A like this. So this matrix is also having rank is 2. This is something that you have done in your mathematics course, but here you don't need to do any kind of calculation. You can just directly use, you can call these functions. Rank is when you write rank and in bracket, you write the name or symbol of the matrix, it will directly give you the rank of matrix. You don't need to write any code or you don't need to do any kind of calculations. Similarly, for this eigenvalue part, eigenvalue, how do we calculate? You no one is saying anything. So we can calculate A minus lambda I is equal to 0. So let's see if my matrix is 1, 2, 3, 4. So I will write 1 minus lambda 3, 2 and 4 minus lambda is equal to 0. And I will solve this determinant 1 minus lambda 4 minus lambda minus 6 is equal to 0. And when I solve this equation, I can get eigenvalues. But in MATLAB, we don't need to do anything like that. We can directly use EIG function. Where did that go? This EIG of A, and it will directly give you eigenvalues of a particular matrix. Okay, so what we covered till now? We covered eigenvalues. Then we covered rank of the matrix. Then we covered transpose of a matrix. Okay, let's say, okay, now let's say I want to clear all this thing. I don't want to keep any of this data. So how can I do it? I will write clear all. Okay, clear all will clear this workspace. And if I write CLC, CLC will clear my command window. So everything is clean now. Okay, so let me define again this matrix. Let's say 1, 4, 3, 2, 3, 5, and 7, 4, 2. This is my matrix A. I am randomly writing some numbers, and let's, as soon as I wrote A and put semicolon, it that variable A is created here. Now let's say I am creating my matrix B, minus 1, 0, 2, 3, 2, 0, 1, 2, 8. So let's say I want to add these two matrices. So how can I add it? Let's say C is equal to, addition can be done by A plus B. So A plus B will give me addition matrix. This summation matrix A plus B. Then let's say I want to do subtraction, A minus B. So that will give me A minus B. Matrix multiplication, we know A into B. So this is my matrix multiplication. Okay, I want to show you one thing. This is my A and this is my B. Okay, and my C is A into B. So this is not this is actual multiplication. You used to do it in your 11th, 12th, and even in your mathematics. Do you remember how to multiply A into B? I hope you remember, right? Multiplication matrix. Okay. So the other thing, let's say I want to do it like it should multiply 1 with minus 1 only, 4 with 0 only. Means, okay, how can I tell you this? Okay, let me write down here. Hmm, it's not getting cleared. Okay, let's say my matrix A is equal to 1, 2, 3, 4, and B is equal to 1, minus 1, 0, 5. Okay, so I want to write A into B such that it do A 1 into 1, 1, 2 into minus 1, minus 2, 3 into 0, 0, and 4 into 5, 20. Okay, I want something like this. That is not actual matrix multiplication, right? If I do A into B, I never get this value. But let's say I want to do this element by element operation. That one first row, first column element must be multiplied with first row, first column element of B, and like that. So what should I do? When I am defining C is equal to A into, that is multiplication only. So I will do A into B. But as it is element to element operation, what I will do? I will put one dot here before multiplication. So what should I expect by this exercise? I should get my matrix as, okay, let me show it here. 1 into minus 1, 0 and 6. My first row should be minus 1, 0 and 6. Minus 1, 0, 6. My second row should be 6, 2 into 3, 6, 3 into 2, 6, 5 into 0, 0. So 6, 6 and 0 I should get. And in my last row, I should get 7 into 1, 7, 4 into 2, 8, and 8 into 2, 16. So I should get 7, 8, and 16. And this is not equal to my actual matrix multiplication A into B. We can see that these two both are completely different matrix. Okay, is this clear to everyone? This element operation we will be frequently using when we are mostly dealing with vectors. Is this clear to everyone?
Yes, sir.
Yes. Okay, so let's say this is my matrix C. Now, let's say I want to multiply C matrix with 0.5. So you can see all elements are reduced by half. So this is scalar into number C. So I don't need to put any dot. But when it is matrix into matrix and you want this kind of operation, you need to put a dot. But as 0.5 is a scalar number, so it will multiply with everyone. So we don't need dot thing here. So this is how we can do matrix multiplication. Eigenvalues we have already done. Okay, one very important thing. Okay, I will first clear all this thing again and CLC. Okay, A is equal to 1, comma 2, 3, comma 3 and okay. So let me okay, tell anyone what is my second row first column element. Second row and first column element. What is that? Guys,
Second row,
For
4.
this is my second row and this
First
is my first column. So what is
Three.
that element? 3. So
3.
let's say I want to get that element second row, first column. So how can I do it? I will write A. I will use this bracket. I will write, okay, first I will write row to second row. Then I will put comma, first column. I will put 1. So it is 3. Correct? Let's say I want to get, okay, let me write down one big matrix. 1, 3, 4, 6, 2, 4, 7, 9. 1 minus 9, 5, 0, 3, 5, minus 1, 10. Okay, this is my matrix. Now let's say I want third row, third column element. What should I write? Third
A
row, third
equal
column.
to A equal to 3, comma 3.
Not A equal to A in bracket 3
Sorry,
comma.
A in bracket. Okay, okay.
So I
If
got
we write,
third.
if we write A equal to 3 into 3, what will be the answer?
No, it will be incorrect syntax. Right.
Yeah.
It will not save anything because this is also
Okay.
not valid.
Oh,
Okay, let me just copy this. Control C. Control V. Okay, so this is my matrix A and I. Okay, let me tell you one thing. Let's say I want all diagonal elements. So what will be diagonal elements? 1, 1, first row, first column, second row, second column, third row, third column, fourth row, fourth column. So how can I get diagonal elements? I will write A 1 comma 1. So that is 1. Then I will write 2 comma 2. Like that I can get. But let's say I want all these entries in one. So what will I do? I will write DIA. I guess it is dia or diagonal. I don't remember that command. DIAG. When you use this DIAG function, you get diagonal elements. So what were the diagonal elements? 1, 4, 5, and 10. So this is 1, 4, 5, 10. These are your diagonal elements of your matrix A. Is this correct? Okay, let's again go to our matrix A. Okay, let's say I want my last column, all last column. How can I do it? Anyone know it?
no, I
Manish?
don't know any cheat codes in this.
Okay, Manish, do you know how can I get
Uh,
all?
Sorry.
How can I get all elements of this last column?
Only 10, like A post
All
at
last column, whole last column, fourth column.
sorry.
Okay, I will teach you how to do it. Anyone, Sambhu, do you know?
Maybe A equals to 4 into 4. No, that will be again for 10 it will come.
Okay, it will come as 10. So when you are dealing with all thing, so what do I mean? All rows and fourth column. So when I am saying word all, I should use this symbol. And I will put comma. This symbol means I am writing it at first place. So what does this mean? What does this mean? All rows. And which column? Fourth column. So it will print down fourth column for me. 6, 9, 0, 10. Is this clear?
Yes, sir. Yeah.
Okay, let's say I want third row, uh, third row and all columns. How will I write it? Third row and all columns. I taught
In
you this. Yes, say
in that case, first third row 3 will be there. Then after that, the symbol will come.
yes. So it will give me my third row. Okay. Let's say I want to print my whole matrix. So it can already directly print it by here. But let's say I want to print it like this whole matrix using this thing. How can I print it? Whole matrix, all rows and all columns. How can I print it?
Column.
Yes. Very good. This is my whole matrix. Okay. Okay. So, okay. One more question. What is the size of this matrix?
4 by
Or
5.
4 by 4.
4 into
4 cross 4.
Sorry,
So
4
let's say
into
I want to get the size of the matrix. So how can I get size? Size of A. I will write size, function size, inbuilt function size, and I will put in bracket and I will write A. So I will get 4 rows and 4 columns. Okay. Let's say I'm having something weird. 1 comma 2 comma 3, 1 comma 5 comma 6, like this. So what should I get size as size? 2 cross 3, correct?
2 into 6.
Correct? 2 cross 3 I
Yeah,
should
2.
get. So 2 rows, 3 columns. So size of A gave me 2 comma 2 and 3. First means 2 rows and 3 means 3 columns. Okay. Is this basic, very basic of MATLAB clear to everyone?
Yes, sir.
This very, you will be using this. Don't worry, don't feel that this is all useless. You are going to use it, and something that I have already taught you here. There is something in your assignment that you may have learned from here. Two questions. If you paid attention,
How did
eigenvalues.
you
Yes, sorry.
sir, how will you identify upper triangular and lower triangular matrix in the MATLAB?
Upper triangle matrix, lower triangle, that I will have to identify. I don't know for now. I will say. I will tell you next time. Okay. Okay.
Okay.
What is the definition of upper triangular matrix? Symmetric matrix and anti-symmetric. I know that if I put A plus A transpose, something like that. But upper triangle means all zeros are in my bottom.
Yeah, in
And
the upper triangle, in the diagonal, in the below,
this is
it will
my
be all zero, and the upper.
wait. I'm sorry. Just a minute. I will write down one matrix. Okay. Let me write down this matrix 1 comma 1 4 5 0 2 6 and 0 0 3. So this is called my upper triangular matrix, right?
Yeah,
So what was your question? How can I identify it?
yeah. How can it be identified? Like if we have 3 by 3 matrix, so how we identify upper
Sorry,
triangular
sorry,
or lower
sorry,
triangular matrix?
sorry. Can you speak slowly? Your and repeat again what you told.
Yeah, yeah. If we have 3 by 3 matrix, so how we can
Yes.
identify the upper triangular and lower triangular matrix?
Oh, that part. That I don't know how to separate those components
Yeah,
using.
yeah.
You're saying that everything this upper triangular 4 5 6. No, that I don't know. I will have to. I don't know if there is something like that directly available or not. Let me check upper. Okay, so one more thing from this question, this is the search tool. You can search something. I will write upper triangular matrix, right? I'm writing upper triangular matrix, so it will give me something. So just wait for a minute. Yeah. So from here we can learn something that we don't know. Okay, TRIU. Okay, very good. And thank you. Because of you, I am learning this. TRIU. When I write TRIU, oh, okay. So what is this TRIU doing? Okay, I understood. Let's say my matrix is A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm writing TRIU of A. Sorry, A is capital. Okay, so what it does,
Yes.
it automatically, okay. And but okay, there was one more thing here. Okay, TRIU, then upper triangular. Okay, and lower triangular, I don't know what it be. LOWU? No, it is okay. No, it will be TRIL, I guess. We can try. I don't know if it is TRIU or L. Oh no, L should be small. Yeah, so okay. This is how you can form your upper triangular and lower triangular matrix from any matrix. Okay. Okay, so this is the help button using which you can find you can type something and it will give you something. So you can learn from here. Okay. So should I close this? We are going to use this help thing today. Okay. So now, okay, I want to cover one important thing, that is, please pay attention because this thing you are going to use in your MATLAB course frequently. Let's say I am writing A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what is 1 to 10 meaning? I have written 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say I want to, in some operation, I need 1 to 100 numbers. So will I be forming one matrix like 1, 2, 3, 4, 5, 6, 8, 9, 10? I will be writing everything by my hand. Should I do it?
No,
Should
there will
I?
be a code for that.
Okay, we don't need even code. There is some inbuilt function that I'm going to teach you, and this is really important. So one part is called lean space. Let's say I'm writing C is equal to lean space. Lean space is, you can also search it here. Okay, let me first explain you, then we will go to that documentation part. So what I need to do, I need to write down my first element 1 and last element 10. So 1 and 10, how many points do I need? I need 10 points. 1 to 10 in interval of 1. So see, I got in between 1 to 10 total 10 points. Let's say I'm writing 1 comma 10 comma 100. So I'm getting total 100 points between 1 and 10. Correct? You can see it here also. Equal points. Equal word is really important. Equally placed points. Okay. Okay, tell me, how do I write? I want between 0 and 100 points. How should I write it? Using lean space command. 0 and 1. Guys, Manish, can you help me? Between 0 and 100 points.
How many places do you want?
100 points between 0 and 1. So I will write x1 is equal to 0. If you can see this syntax they are giving. First I will write x1, then I will write x2, and I will write 100. Okay. So I got between 0 and 100 points. Okay. Is this clear to everyone? Okay,
Yeah.
what happened here? In between 0 and 1, I developed some points, but I don't know what is the interval between. I don't know this interval, right? It will be equally spaced, 0 and this point, 1, this and this point. These points are equally spaced, right? But I don't know this interval. But let's say I tell you that between 0 and 1, uh, I need to reach from 0 to 1 in gap of 0.01. So can I use this thing? Lean space part? Between 0 to 1, I need to move from 0 to 1 in gap of 0.01. Are you understanding what I am saying? So let's say my first point is 0, my second point should be 0.01, next should be 0.02, and like that I should reach till 1. So I don't know how many points will be there. So can I use lean space command here? Can I use
Yeah,
it?
yeah, but in second x2 will be different again. X1 will be same 0. X2 will be different again.
But we no, you're not understanding what I'm saying. My x1 and x2 are fixed. 0 and 1 are my 0 is my starting point, 1 is my end point. But I don't know how many points will be there, but I need to increase in interval of 0.01. I'm saying that. So I don't know how many points will it be there in interval of 0.01. So can I do it using this lean space? I can't do it, right? Because in lean space, I need to give first point, end point, and number of points. But here we don't know number of points. Here we have interval length. h value. So for that, what we will do, I will write 0 in interval of 0.01, 1. I will define it as a is equal to, I will write it like that, 0 in gap of 0.01 to 1. So see, all points are in interval of 0.01. So let's say when you are dealing with your boundary value problems, right? And then you need to, let's say your length of the rod is 10. So you will need to discretize your length, whether in equal points or whether in interval h that you are giving. Okay, so any one of the way you can do it. The only difference is lean space you need to give total number of points you need in between, and in this method when we are using directly like this, you need to give the interval. So in interval we don't know how many points, and in this how many points we don't know what is the interval. We can calculate obviously, but we don't know beforehand. Okay, so this is really important and this is going to be useful. Okay, is this clear to everyone?
Yeah, it's clear.
Let's say I want to find square root. So square root is SQRT, square root of 2. So it is printing this SQRT of, let's say I am writing -1. So it is giving I, right? I square is equal to -1. So square root of -1 is I. Let's say square root of minus 76. So it will be something like this. Okay. Okay, so this is all about very basic part of MATLAB. So, okay, let's take some questions, MCQ kind of questions that will be useful for your assignment submission. Did you solve your assignment? Anyone?
Not it's
Okay. Did you check your assignment? How many questions are there? Are those questions easy or not?
I guess there are 20 questions.
Okay. Anyone other than him? Manish, have you solved?
Yeah, of course. Let me check which I have solved one first assignment, but I didn't see the second assignment.
Okay. Okay, so let me I have some questions from previous year's assignments. So let's try and understand those questions, and I guess it will be useful for you too. Just give me a minute, guys. And where else I have written something? I need to clear it out. Okay, yeah. Okay, first lecture will be a bit boring because we are not starting anything with MATLAB. We are just understanding very basic features of MATLAB. But when from the next lecture, we'll be starting to write some simple codes. So it will be getting more and more interesting with time. Okay. So let's take some examples. Let's take some questions. So this is the first question. What is MATLAB stands for? What is the full form of MATLAB? I already told you in our slides. Anyone?
Matrix laboratory.
Matrix laboratory.
Laboratory, correct. So the full form of MATLAB is Matrix Laboratory. Okay. Next question. Compiled languages provide better cross-platform compatibility in comparison to interpreted languages. Is this correct? Okay. Let's go to theory part. It is on page number 47. Okay. So let's go to that part. Okay, so there are two type of languages, compiled languages and interpreted languages. C and Fortran are compiled languages, while MATLAB and Python are interpreted languages. So what is the difference between compiled and interpreted languages? We can see it here. The complete source code is translated to a machine code in one go, generating an executable file in compiled languages. While in interpreted languages, each line of the source code is translated to machine code and immediately executed. So see this line, this sentence, each line of source code is translated to the machine code and immediately executed. So we check this here. Let's say I wrote something 5 plus 3. So this line, it converted into machine code and it is immediately executed. So this is the benefit of interpreted language. Then other thing is execution is faster because whole file is getting translated into machine code, and this is interpreted language is slower because it is doing line by line. Then compiled language as yeah, as we are whole converting our whole code into machine code, error in the code results in the failure of compiling code. While in interpreted language, we can do partial execution and we can even identify, we can do step by step, line by line execution, that I will show you how can we do it. And in compiled language, cross-platform compatibility issues are there. While in interpreted languages, no, it is better cross-platform compatibility. What is cross-platform compatibility? Can anyone tell me?
We can use it in Aspen, something like that.
No, no, no. That doesn't mean cross-platform. Oh, sorry, my window is okay. What is cross-platform? Sambhu? I guess sir has covered this in lectures.
Sorry, I do not remember
Okay,
it now.
it's fine. It's fine. Manish, you remember?
Not it.
Okay, cross-platform meaning in different operating systems, like from Windows to Linux, like that. So here we have seen that it is written that for compiled languages, there can be cross-platform compatibility issues, but interpreted language, it is better. So our question was, the compiled languages provide better cross-platform compatibility in comparison to interpreted languages. Is this true or false from the theory that we checked? It's here only. First read this.
So
No, it's false. Interpreted languages provide better cross-platform compatibility, not compiled languages. So the question is, compiled languages provide better cross-platform compatibility in compared to interpreted. That is wrong, right?
Yeah,
Interpreted
yeah,
languages provide better. Okay, is this clear to everyone?
yeah. It's clear.
Yes, very good. Now let's move ahead. We'll do it slowly. Okay, so the question is, which one of the following is a system that can be best described by spatio-temporal formulation? Before moving anything ahead, what is spatio-temporal formulation? Guys, what is spatio-temporal? What does spatio word means? Spatio means with space. Space means with coordinates x, y, z, and temporal means with time. So which of the following is the system that can be best described by as well as space as well as time? So when we write continuous stir tank reactor, mass balance of continuous stir tank reactor, it is just with time, right? Let's say I'm writing dCA by dt is equal to K into Ca. There is no term of space in CSTR part. But what is transient? What is tubular reactor? Tell me. Forget about tubular reactor. What is plug flow reactor? Can anyone tell me what is plug flow reactor? Manish, what is plug flow reactor? Rohit?
Plug flow reactor, it's like reactants enter at one point and uh, whole concentration of reactants will be same in the reactor. That is plug flow reactor.
In the
In
length, or there is no mixing, radial mixing is not allowed, right?
yes, radial mixing is not allowed in plug flow reactor.
So space part is there in plug flow reactor, and I can also see that variation with time, that t is equal to 0 at x is equal to 0 location. It was this concentration. After some time, it changes. So tubular reactor is also similar, that there are tubes in the reactor. So tubes, it will concentration will vary along the length of the tube and along the time of the along the time. So my answer should be transient tubular reactor. Is this clear, guys? Have you checked the what is it called? Have you checked the lectures or not? I don't know. I will show you. Yeah, here. See, temporal, spatial, and spaces. Temporal, spatial, temporal, and spatial. So this model we can see that this temperature is only varying with time. In this spatio-temporal model, temperature dt by dt, temperature is varying with time as well as with space, that is x, y, z. And in spatial model, temperature is only varying with x, y, z, that is location, not in time. So this is called temporal, this is spatio-temporal, and this is spatial. Okay. Is this clear, everyone? Sambhu?
Yeah, it's
Okay. Please stop me if you are not understanding anything. Okay, let's move ahead. Next question. Okay, this question Manish will be solving, and Rohit also, I know you can do it. It is required to prepare 1250 kg of solution composed of 12 weight% of ethanol and 88 weight% of water. Two solutions are available. The first solution A contains 5 weight% ethanol and B contains 25 weight% ethanol. And we are mixing it. So how much of A and B are required? So this is the diagram where we are having in one case solution A that is 5-8% ethanol, so rest 95% is water, and solution B that is 25% ethanol and rest 75 is water. And I want solution of total 1250 kg that is composed of 12-8% ethanol and 88% water. So how should I write down my equations? Rohit, one overall balance A plus B is equal to M, correct?
A plus B equal to 1250.
So my first equation is A plus B is equal to M, that is equal to 1250. Then I will write ethanol balance, that is A into 0.05 plus B into 0.25 is equal to M into 0.12, and M we know 1250. So 0.12 into 1250. So we have two equations, we have two unknown. So we can solve this equation, right? Can you solve it and tell me what is the answer? I will wait for a minute or 2 minutes or until you are solving it. It has started raining in Mumbai just now. Okay, solve it and tell me. What will be, we don't really need this equation. We just need, we are having only two unknowns A and B. So we need only two equations. Okay, anyone solved it? Ambu,
okay, done, sir.
what did you get? What did you get as A and B? Okay, can anyone please confirm?
A is a 0.65 of M, 0.65 into 1250.
Equal to 50. Okay, whatever is the answer. So okay, one thing. This is our MATLAB course, right? So why should we do it on using pen and paper? Right? Why should we do it on pen and paper when we are learning MATLAB? We can use inbuilt function to solve it. So let's say I'm using this symbol is used for comment. Okay, let me first clear everything. See. Okay, let's say my first equation is a plus, where is plus? Yeah, a plus b is equal to m, that is 1250. And my second equation is, can anyone tell me what is second equation? 0.05a plus 0.25b is equal to
0.12 m.
0.12 m. Let's do one thing. Let me write down m here, and I will write m is equal to 1250.
Okay.
50. Okay, so I want to solve this. So what I will do, I will first create matrix A. Okay, let me not write A and B because it will be confusing. Let's go for X, Y, Z. So X is equal to, what I will do, I will write down the coefficient of my first equation. So coefficient of A is 1 and coefficient of B is 1. Okay, and I am closing it. In my second equation, I am telling it y is equal to 0.05, then 0.25. Okay. Okay. Okay, let me show you one more thing I want to show you. Let me write it down like this. It will be more clear. Okay, so what we did, we wrote a comma b coefficient 1 comma 1 and 0.05 comma 0.25. Now I want to write this right hand side matrix. So right hand side is, I will be entering first value then second value in columns, right, the way equations are. So I'll be writing z is equal to, what is the value, 1, then I will put semicolon 0.12. And what is the value of m? I will just multiply it with 1250. So instead of writing 1250 and 0.12 into 1250, I wrote it like this. I have x, y, and z. So now tell me one thing. My, okay, let me show you. My equation is 1, 1, 0.05, 0.25 is equal to 1.12 into m. So I want to write my this term like this, 11.05.25. So how can I write it that? How can I write it that? This first row, then it will be second row. How can I do it? I'll be writing, or instead of doing it, let's do one thing. Let's write x is equal to, let's first write first, um, what was I saying? 1 comma 1, then semicolon 0.05 comma 0.25. So will it show it like this, right? And my z we have already written is equal to 1 colon 0.12 into 1250. So sorry, it is 1250. It's like this. So I need to solve it x comma z. So what I will do, I will use command lean solve. I will put x comma z. So it will give me a is my 812.5 and b is my 437.5. Did you get it what I did? I just wrote my equations the way we write here. This was my equation, a plus b is equal to m. So 1 comma 1 and 0.05 comma 0.25. So first I wrote my first row 1 comma 1, then semicolon, second row 0.05 comma 0.25. And my this z matrix, right hand side matrix, that is m comma 0.12 m, and that is in column. We can see m and 0.12 m. It's one after another. So we have written it in column format, and then we need to solve it. So it's just lean solve x comma z. Did you get it, guys?
Yeah, yeah.
Let's say I want to solve this equation. Can anyone help me? How can I solve it? Okay, let me write it down like this so it will be easier for you. Okay, can anyone tell me how can I solve for A and B? Just forget this thing. This two. How can I do it? I will first write my left hand side matrix. How can I write it? Sambhu, can you tell me? First, I will write coefficient of A, comma B in first equation, then colon. So it will be going, we are going into next row, pi, comma 3. So this is my X matrix. So it looks like this 1, 1, 5, 3. And my right hand side matrix Y is equal to X equal to 5 and 6. So I will write 5, colon 6. And I will use lean sol X, comma Y. So it will give me solution. Okay. Guys, are you understanding it or not? Okay, let's move ahead. Anyway, we are going to learn this in detail in upcoming classes. Okay, so moving ahead, compute a sum of 100 equally spaced number between 0 and 1. So first what will we do? We will be doing 100 equally spaced numbers. So how can I do it using lean space command, right? I will write lean space between 0 and 1. So 0, comma 1 and 100 points. So let me call this matrix A. A is equal to this matrix. Okay, and I want to sum it. So to sum all the elements, I just need to write sum command. This sum command take the summation. So if I write sum of A, it will give me the summation of all. So that is 50. So this sum command is used for this purpose. Okay. So let's move ahead. The task is to determine the number of elements in the vector X. Number of elements means size of the matrix. And store it in a new variable n so that n should be equal to 5. So let's say my X is equal to 149, 16, 25. X is equal to 149, 16, 25. So what is the size of this matrix? Anyone? What is the size of this matrix?
1 into 5.
One row, 5 columns. I will be, if I want to find a size, I will be writing size as size of X. So I got 1 comma 5. But what they have told, we need answer to be equal to 5. So how can I get answer to be equal to 5? So I will write size of these terms second column. So I will write X comma 2. So that will give me 5. Let's say if we were told that answer should be 1, I will be writing 1. So what should be answer here? I want column. So n is equal to 5. So I will be doing this size X comma 2 the way we did to get 5. Is this clear? Guys, please respond. I'm not understanding. If you are okay, the question is what is the output of the following command? Eval of X is equal to 5 plus 3. What does eval do? Eval evaluates the function that we are giving. So if I am writing eval of X is equal to 5 plus 3, what should I get? What is the value? What will be the value of X? What will be the value of X? Guys, what will be the value of X? Anyone? X will be equal to 8, right? 5 plus 3. So my answer will be 8 is really simple. Then my next question is, which of the following are valid commands for different graphing features in MATLAB? So I have these commands given histogram. So if we go to this plots option, so we can see that histogram is there, right? So I can plot histogram. Then surf command, surf is surface plot. So surf is also there. That surface plot we can also plot. Bar 3h. So where is bar 3h? Is there any bar 3h? Can anyone see bar 3h? Bar 3h is nothing but bar graph in horizontal way. Let me show you here. Bar 3h. It will be loading it. So when I write bar 3h kind of plots, it will give me horizontal three-dimensional bar plot. So this is how it looks like. And the last is contour. Contour plot is already there. So all options are available in MATLAB. So all options are valid options, correct, for plotting. Now the next question is, which character is used to print new line in fprintf? So let's go to fprintf here. Fprintf. So I will be choosing fprintf here. So let's say this example. A is equal to 1.02, 3.04, 5.06, and I want to print it as round off value. So what is the round off value of 1.02? That is 1. 3.04 is 3 and 5.06 is 5. But what do I need it? I need it in one after another line. So 1 should be in new line. 1 then 3 should be in new line. So that is done by this slash n. This thing you will be learning in upcoming lectures. So this slash n, we can use it to print it in new line. So the answer will be this one. Okay, the next question, okay, this is the repeating one. So we want to see this. Okay, which of the following is the assignment operator in the MATLAB? Let's say I want to assign the value of x, 3x is equal to 3. So how can I assign it? Which operator I can use to assign?
Dollar.
No, x is equal to 3. So 3 is assigned to x. So how did I assign it? I assigned it using equal to sign. Right. Right. A is equal to 3. What does this A equal to 3 means? Value of 3, I am assigning it to the A. Let's say B is equal to 10. So value of 10 is assigned to B. So this assignment of, we are assigning some value, so that thing we can do it by using equal to operator. Okay. Oh, I'm not able to. I don't know why. It's gone. Okay. This 12th question, we will not do it right now. We'll go to next question 13. Okay. In MATLAB, which command is used to add text label x-axis? Okay. So before that, we need to see plotting part. Wait. Let's say my x is equal to 1, 2, 3, 4, 5, and my y is also equal to 1, 2, 3, 4, 5. And I want to plot x comma y. So to plot, we need plot x comma y. So using this, we can plot it. So if I do this, I should get a straight line, correct? So see, I got a straight line. But let's say I want to label my x-axis and y-axis. So to label that, I can write x label, I will write it as x, correct? And on, okay, it updated, but yeah, here. So see, x came out. And let's say I want to write down my y label as y. y. So this is the command. This is the command for x label and y label to give the name of the axis. So what will be the answer here on the for the question number 13? Anyone? What will be the answer, guys?
X label. X label.
X label. Simple. Okay. Next question. Which of the following is an interpreted language? So C and C++ are interpreted, that we already know, right? We see here. No, C and C++ are, sorry, those are compiled languages, not interpreted. So this C, C++, those are compiled languages. But we don't know about these Swift and Ruby languages. So let's search it here. So Ruby, LA and GUAGV, Ruby language. So it's an open source programming language which focuses on it has. Okay, so it is writing. So I guess this is interpreted language, not the other one. Other one was Swift. No, Swift is not interpreted language. Swift is a compiled language like C and C++. I guess that is some Japanese developed in Japan. And this is compiled language. That is mainly for this iOS operating system. Okay, so that is Swift language. So our answer for this question will be Ruby. That is interpreted language. Okay, which is the invalid variable name in MATLAB? Can anyone tell me? Which name I cannot give? Okay, let's go from here only.
6x.
Let's x6, yeah, correct. X6 is equal to 1. Okay, so that is working. Then the second one was last. Last is equal to 1. That is also working. 6x is equal to 1. So that is not. Can anyone tell me why it didn't work? 6x is equal to 1.
Numerical part is coming front.
Yeah, numerical part is coming. That's why. I can't even write this. Sorry. I can't even write like this. Yeah. Good. Okay, so that is the. This we can't define it like this. Okay. Next question. Okay, you will tell me the answer. X is equal to 2 into 3, then there is one semicolon, and y is equal to x into 2. When the above commands are executed in MATLAB, what is the answer that we should get? We don't need to run it. We can do it.
6 and 12. X6 and
What is the answer that will be printed on command window?
A option.
No,
No, B option. B option.
no, not even B. Can anyone tell? See, there is one semicolon
C.
after
C.
x is equal to 2 into 3.
Okay. C option.
No, not C.
Not
C.
C also.
C. X is
Okay.
equal to. Wait. X is equal to 2 into 3. After that, there is one semicolon. So what it will do, it will not print anything. Semicolon. And what is written then? Y is equal to x into 2. Y is equal to x into 2, and there is no semicolon. Correct? After that, there is no semicolon. So what it will print? It will just print value of y. And that will be a as x is equal to 6, y will be 6 into 2 is equal to 10, 12. Correct. So it will only print y is equal to 12 because there is no semicolon present after y is equal to x into 2. Is this correct? Did you understand?
Yes. Yes.
These things you will be more getting once you are getting more familiar with coding and you are doing it on daily basis, so it won't be big issue. Okay, so next question, last question. Which function is not provided by MATLAB mathematical function theory? So eigenvalues, you know that I show you we can calculate using EIG function. So eigenvalues is there. Let's check for Bessel functions and Fourier transforms. So let me check for Bessel functions. Okay, Bessel function Fourier transform. There is a different theory that I will not be covering for now, but there is something that you can see. These are spatial functions: Bessel, Legendre, elliptical, gamma, others. So when you want to calculate some kind of Bessel function, so you need to call this function Bessel y, Bessel function of second kind, Bessel k modified Bessel function of second kind, Bessel g Bessel function of first kind, and Bessel I modified Bessel function of first kind. So this you can directly call it. So you don't need to write any code for this part. Okay, let me click it here if there are some examples available. Yeah, it is complicated. These kind of functions are called Bessel functions. So you can directly call it by writing Bessels. Then the other was Fourier transform, right? So let me check Fourier transform. Fourier transform is also available. You can also calculate Laplace transform. So Fourier transform is by FFT. Fourier transform. Discrete Fourier transform. Okay. So you can calculate Fourier transform of any function using this FFT command. Okay. So these all are available. So answer will be none of the above. Okay. Guys, is everything clear to you? Manish?
Yes, sir.
Okay, so can you solve assignment now? I guess there is nothing much about assignment. There is only one thing about eigenvalues, how to calculate it that I have already mentioned. So you can do it for your own question that how can you calculate eigenvalues. Okay, are you having any other doubts in week one content? If you have, you can ask me anything other than what I covered. Okay, so I guess it is clear to everyone. So this was what taught by Professor Parag in. Okay, someone was saying he or she knows Scilab. What is Scilab? And means what does that do? I don't know. Okay, that is
Yeah,
also
it's same as like MATLAB. I have already used this. The same function. If we are using the MATLAB, it's work.
okay, and it is open source, right?
Yeah, it's open source. We can use.
You don't need anything. Okay, this is good thing. I was not knowing. I have never used this Scilab thing. Are you knowing Python? Are you knowing Python or anything other than this?
Yeah, I have used the Python, but not sorry. I know C plus C
Okay, so
programming.
okay, C is more painful, like because there are no inbuilt functions. You have to write down everything by your own. Like the MATLAB have to calculate eigenvalues, you can directly call EIG. To calculate rank, you can directly call RANK rank. Okay, so this is what it was covered, and I can't do it. Just a minute. Mm, I'm sorry, just a minute. Where did it go? Yeah, here. So this was all from my side. So thank you so much everyone for joining. And if you are having any query, you can write an email to me regarding assignment. If you are facing some issues or you are not understanding something, you can write me an email or anything in lecture that you are not able to understand. I will try to help you as soon as I can. And this is my ID. If you want, this today's lecture will be uploaded on this site, so you can check on YouTube. Okay. So for any query, feel free to write me. Okay. So I guess we are done with today's lecture. So we will meet next week. Okay. Okay. Till then, take rest and enjoy. Bye bye.
Okay, thanks.
Bye.